propeller, you notice it has a huge amount of blade area compared to this one. Okay, so as you can imagine, this big propeller takes more power to turn, but it also means that with the same amount of power, it turns slower. And we're powering our airplanes with a rubber band, which can only carry a finite amount of energy, and that energy is not released in a linear fashion. So this propeller is also designed to be modified in such a way that it flexes, that the blade actually will flex under load. And that flexion is called flare. And flare increases pitch. So this propeller can be modified in a way to make it act like variable pitch. And real airplanes have variable pitch that's in-flight adjustable because it makes them efficient. And that's exactly what it does for us in the model airplane. By sanding this blade and adjusting the thickness of this spar, the prop spar, we can make the blade flexible and make it flare. And flaring props are legal with an L, not illegal. Mechanisms to make it do that are illegal, but flaring props are not illegal. So these props are made by KYTSA. They're made in the Czech Republic. You don't have to use a propeller that's made anywhere. The rules used to say, up until this rule cycle, they said that the propeller had to be a commercially available plastic propeller. Okay, I had a long conversation with Dale Mall at the national conference in 2019, and I think I was able to have some influence and say, hey, let's do away with that commercially available plastic part of the propeller rule and let students experiment with propellers. So now a student can actually fabricate their own propeller out of any material that they feel appropriate. And as long as it fits the diameter rule, which is 170 millimeters in diameter, they can run any prop they want to. So we need to cut this propeller down because as it comes from KYTSA, it's too big. So let's see how much too big. So let's throw a ruler out here beside it. This propeller is 22 and a half centimeters or 225 millimeters, and it's only allowed to be 170 millimeters. So to be quite honest, the way I have the students trim this down, I use calipers. I use calipers because you can stick one point at a caliper in here. You can set it to the 85 millimeter radius. You can scribe the line with the other point of the caliper, and then just cut it off with scissors. And that is the easiest way to do it. We can do it some other ways. We can do it with a ruler. I had a ruler in my hand sometimes. So we can do it with a ruler. It's a little trickier. I'm going to use some tape to try to do that. You can measure straight across and cut it, but again, depends on how the judge measures the diameter of the prop. One way that it could be done is they could have a hole cut in a piece of wood or a piece of cardboard that's 170 millimeter circle. And if your plane won't go in it, if your prop won't go in it, it's illegal, right? So if you just cut it straight across, if you just make a line straight across, the distance from the center of the hub to that line might be set 85 millimeters, but not on this diagonal. It's too long and it won't fit. The corners would hit. So we're going to do it. We're going to make sure that we are legit. I'm going to use done. So I'm going to take a piece of wire and I'm going to tape it to my ruler at 0. Okay, so I just taped it on there. I taped it at the 0 mark. And now I'm going to take another piece of wire or a straight pin or my X-Acto knife, probably another piece of wire. You could use a pencil if you wanted to. You can do this with a compass. You can do it in lots of different ways. So think creatively how you would do this. I'm just going to use an ink pen. And I'm going to come out here so that the point of my pen is at 85 millimeters. Like I said, problem solving is half the joy of this contest. And figuring out all the different myriad ways that you can get disqualified. That is also part of the joy of this contest. We had been to the national conference a number of years. I'd had top 10 finalists. We were still using Midwest Sorcerer for the competition, and we were using the drawing out of the Sorcerer kit because it said you had to have a technical drawing of an airplane. They gave you one when you bought the kit, so we were using that as part of the portfolio. So you see now I made myself a little fake compass here since I didn't have one, and it's just my pen and a piece of wire. I put the wire in the hole in the middle, and I just can mark around like that, and I made a mark on my blade. I do it on the other side, and make a mark on the blade. So I made 2 marks on my blade, showing my 85 millimeter radius, which is half of my 170 millimeter diameter. Now I'm going to borrow my scissors back real quick. And I'm going to take this and just cut that off. Yeah, there's a huge amount of area left for exploration in our program here with propellers. So I've only had a couple of kids really experiment with propellers. My best student time here is like in the 3 minutes and 15-second range, which is reasonable in a 20-foot ceiling. We went to state conference. I'm trying to think. Andy, were you there when I flew 4 minutes?
Oh yeah.
So in a few years ago, I built a plane, and it was my first tandem. A tandem again is a plane that has a wing for a stabilizer essentially, and it was right down at the minimum weight. And we were in Hampton, Virginia, at the state conference, and it's a 32-foot ceiling, and I flew 4 minutes and 9 seconds with that airplane. So there's a lot more to be had here. Huh? Yeah. Yeah. Yep. So yeah, we have some little friendly rivalries in Virginia about airplanes, either gliders. I know that some of you may have done middle school or seen middle school before. My friend Matt Short in Middlesex County, he built glider. If he flew 28 seconds with a middle school TSA glider, which is just unbelievable. I'm like, how in the world do you do that, son? I don't even really understand. But anyway, it's terrific. But so now we have our propeller down to the size. We have our little wire. Now comes the part where we got to put that together. And when we do that, we'll have an airplane. So we're getting there. So in your kit, you should have Also taped, I think taped to the little piece of black cardboard that that the razor blade was hooked to. You should have some washers, and I have a few more. Till I got to keep up with them somehow. So we're really just going to use 2 of them. These are made out of Teflon. I used to use glass beads for the longest time, but Teflon is so much better. The glass beads the sides aren't parallel, so you end up with thrust line of changes that, change when the plane's flying along. We tried many times, always tried to do stuff the cheapest way first. And when that didn't work, we just tried the next thing. But we didn't spend money until we figured out that we had maximized what we were going to be able to do consistently with what we were able to do cheaply. Like I said about making thrust bearings, I used to the little hanger bearings. I used to make the kids make those, and they would just get so mad, like they would break drill bits, and I'm like, yeah, just keep at it. You're learning craftsmanship. So I didn't laugh when I told them, but I'm laughing when I'm telling you guys. All right, so we take the propeller, and we put the 2 washers on the prop shaft, and then we put the propeller through the hole. Put the wire through the hole in the propeller. Then we got to bend this over, and we got to figure out where to bend it. So we want to bend it so that when we bend it down, we're going to bend the tip of the wire down. I am not holding it in the camera again. We're going to bend the tip of the wire down in the same direction that the open side of the hook is. So like if I lay it flat like this and the open side of the hook is towards me, I'm going to bend the tip of the wire down so that the bent tip is bent towards me. And I need to bend this more than 90 degrees, but I need to know where to bend it. So I need to put this in the airplane. So I'm going to take the wing off, and I'm going to take the tail boom off. So I got mine sitting here all together. So I'm going to take those things off. So I just got the motor stick. And now I want to try to I'm going to fish all this together the way we would have to put it together at the competition. I turn it upside down, and I hook it like I'm baiting a hook here. I put the one short leg of the hook in the hole. I say that, there it is. And then I'm going to just work my way around. Notice that I put it through from the front, and I just keep working my way around until I get it to go through there all. There we go. And then I can lay that angled piece of the diamond right in the slot and push it through.
Why wouldn't you just take the propeller off and slide it through?
Oh, you could. Yeah, that's the easy way. Come on, man. Why do you want me to do things the easy way? No, you're right. That's exactly what you could just put the wire through there from the back, and then put the 2 washers on there, and then put the prop on there. That's the easy way. But I also was just demonstrating how you have to assemble it. Once you bend the wire, you got to put it on that way.
Okay.
So
Bryce, you can put this.
So I was one of those using a glue stick, and so I missed how long you said to cut the propeller was 170.
Correct. Yes, that's right. 170 or 85 millimeters from the center to the outside. 85 millimeter radius, 170 millimeter diameter. That's correct.
Thank you.
Uh-huh. So I've put the wire through now, and you can see that I've got the hook with the open side facing down toward the wheels. laying against my middle finger so that it can't turn. Okay, and now I can take the propeller and put that on the wire. And now I can grab, I'm going to push this forward as far as I can get it. And then I'm going to take I have a little bit bigger pair of needle nose pliers. And I'm going to grab it. I'm going to grab this wire right past in front of the propeller. And I'm going to go up to about the 4th groove in these bigger pliers. Like that. And I'm going to then bend the end of this wire. Y'all can't see a thing. My hands are right in the way. Andy, you're slacking on me, man. You're not telling me you can't. I give you you can't see it. So then I'm going to take that wire and I'm going to bend it in the same direction as the open side of the hook. So in this case, now I've got it. I'm holding it. I'm going to bend it away from me. I'm going to bend it down away from the camera. And I'm going to push that with my finger and go past 90 degrees. Not much. Like, let me hold it up here so you can see. I had to go, oh, that's a little too far. Okay. So, let me get it back in the hole here. So now when I put it back like I had it a second ago, I'm holding the motor stick. This wire, when I pull it back, it matches the angle of that ramp on the front, that little ramp that you can see on the front of the propeller. Now some experts will tell you to glue that in, to glue the wire in. I've never done that. I've always left it as a freewheeler, which is what this ramp does for you. It allows the prop to spin when the rubber band winds down. If you're doing things right with your rubber and propeller selection, the rubber band, it's never going to glide. Your airplane will never glide. But I wanted to have the opportunity, if it does have to glide, to let the prop freewheel. And then we're going to get rid of all but about 1/8 of an inch of this excess wire. And I'm just going to cut this and cut it so that I'm leaving about 1/8 of an inch as to catch. 1/8 of an inch of this catches the freewheel clutch, the freewheel ramp. And the reason that I made it so that that angle was the same. So when I'm holding the airplane like this, see, I'm pinching the propeller between my thumb and first finger. And I'm trying to hook the rubber band on here. The hook is facing down so that I can get to it. If I didn't take care to line that bend in the right angle, my hook could be over there like that, or my hook could be over here like this. And it's important that we can get to the hook. We got to be able to put the rubber band on the airplane. So we end up with something that looks like this, with our propeller cut down to 170 millimeters. Now I can see on mine that my landing gear legs are too long. I just guesstimated. It's okay. You can make them, that's another way to economize as far as weight. Don't make the landing gear any longer than it needs to be. Why carry all that weight? You don't need it. But it's fine for what we're doing here. Again, I didn't do that from the drawing. I didn't have it printed out. I just guesstimated. So that's the last step. Once we assemble the propeller and put it in the hook and bend that wire over, put those 2 washers on there. Now we can put our stab back in there, our tail boom back in its little socket.
Before you move off the propeller, I've got my propeller on. I put the 2 washers on and then the propeller, and I'm ready to bend the wire. And you said to bend it.
You want to bend it down, so it's in. When you bend it, you want to bend in the direction of the open side of the hook, so that you want the plane of the hook and the plane of that piece to be in the same plane. Let me hold it sideways and I'll show you. So here, am I under the camera okay? So there's the hook. See that the open side of the hook is facing down, like towards the wheels. And then see over here, I have the wire, it's bent down. It's bent in the same direction.
Sounds like, okay.
I just want to make sure I bend it in the same direction so that when I'm holding the plane to put the rubber band on it, the hook is open to the bottom. Because otherwise I'll fight it. It'll be like two seagulls fighting over a fish head.
Thank you.
Yes, ma'am. So we can put the tail boom on there. And we're going to just stick it in because we're going to see in a second that we're going to have to move our wing saddle to adjust our balance. Right.
Billy, maybe I missed something, but the wheels, the landing gear,
Uh-huh.
not very loose.
What do you mean?
I mean,
Did you glue it on?
no.
You got to glue it on. The super glue.
That's what I said, maybe I missed something.
You missed the super glue. Andy missed the super glue guy.
Yep.
That's okay. So we end up now we have our whole plane. It's assembled. Now, if you had the chance and you pre-built your stand, then you have a place to hang your airplane when it is done. Okay. Now break the stand. Luckily, it's like a production line, man. I have interchangeable parts. So, so now we can take our plane and put it on our stand. And of course, you guys can't see that at all. So I'm going to switch cameras for a minute, guys, so y'all can see. Maybe if I can even move the mouse on this computer. So you see we have our stand, and here's the stand, how it goes together. This one's a little taller than yours just because the dowel is longer. And we just clamp it here with the clothespin. And that when you have a plane in the shop, you want it on a stand because when people walk by, it'll blow off the table from the breeze from somebody walking past. And then the other thing, that's why you made a box. If you ever got to carry your airplane anywhere, you need a box because nobody cares about your airplane but you. And people in the hallway will just walk into you when you're carrying it. So have a box. So we should have our finished airplane hopefully in the next few minutes. The plane should balance around the back of the wing. So you see on this one, it's tail heavy. Notice how I'm holding it at the back spar and it's tail heavy. So I need to move the wing back. So this is where the advantage of having this adjustable saddle. I can move the saddle back and see how I slid the saddle back, and now my plane balances at the back. It balances at the back spar. Still needs a tiny bit, and really it's you can't get balance perfect until you put the rubber band on it. We start out with a balance point at the back spar. And if you get your plane to balance at the back spar, you're in pretty good shape. So what we're going to check now is see how we did. We're going to check with the scale. The scale tells all. We want to see if we're in that under 8 gram range. 7 is the minimum. 7 is the minimum, and we're going to see if we're close. All right. So having good scales, guys, is another important thing. You can get a nice scale for about $20 from Amazon. And so this one is right at 8 grams. This is 8.0 grams. And I knew I was going to be heavy. I knew I was going to be somewhat heavy because I was about 400 milligrams over because of my motor stick. So again, 8 grams, I'd be content with that for a beginner's plane. This plane is straight, and it's going to be, it'll be okay. It'll fly just fine at 8 grams. Got no issue with that. I'd rather it be straight and 8 grams than warped and 7. Yeah. So we've finished the construction of the airplane now, and the only thing left for us to do is to make a motor. So I'll let everybody catch up. We'll take. I know it looks like we're supposed to end at 4, but just kind of want to touch base on the rubber bands real quick before we stop. And I'll be here. I'm not in any kind of rush. So if you guys want to ask questions or want to, whatever, I'm fine. I'm fine. All right. So let's talk about rubber band. All right. I'm gonna switch the cameras back here. I can do it without breaking my model. All right, so the rubber band that we use is special. The rubber band here, here's that scale that I told you about, $20 scale. Weigh gram, $20, top 100, goes up to 100 grams. It is accurate. It's accurate to 1/100 of a gram, and it's all you need for everything that you want to do. I also would recommend shopping around if you're going to get into this. Get you a thickness gauge. I have a couple. I have one that I keep on my workbench and one that I keep in my model toolbox that I take to contest. So the rubber band that we get is called Tan Super Sport, and it comes from FAI Model Supply. It's really the only supplier that I'm aware of. Rubber band comes in vintages like wine. So the best rubber that was ever made was May of 1999. And if you can find May of 99 rubber, I've seen people that are in the expert classes, FAI models, pay $5 a gram for rubber band. So a pound of rubber band, they pay over $2,000 for it. It just is that much better. It's a little bit better than the next best batch. And when you're trying to fly 40 minutes, not 4, 40 minutes with a rubber band powered airplane indoors, you need all advantage you can get. So the rubber band comes in different stock widths. So you can buy it 1/16, 3/32, 1/8, 3/16, and 1/4. So it comes in a strip. It comes in one long piece. If you look around, you can find splices in it every once in a while where they splice the sheets together. So here's a strip of rubber band, a piece of 1/4 inch wide strip. This is actually not Tan Super Sport. This is Tan 2 from way back when. Pretty decent rubber still. The thing you'll run into is that trying to use the stock sizes will limit the performance of your airplane, because 1/16 might be too small and 3/32 is too big. So you're like, well, what do I do? Well, there are suppliers that will sell you pre-cut, pre-stripped rubber band to whatever size you want, but you pay a premium for it. So the alternative to that is to strip it yourself. So I have more goodies from my toolbox here. I'm sorry I had to walk across the room to get them. So the first tool that we really invested in is anything special that was just for model airplanes was this. This is a rotary shear made by Ray Harlan. This is a very nice precision instrument. This tool probably now is like about $175. You can see it's got two blades on it, one at the top and one at the bottom. It acts like it's a rotary shear, so it acts like scissors and it shears the rubber. You set the two guides with the micrometer dials, and you feed the rubber strip in on one side. I'll cut a little piece and I'll show you. So we'll adjust it for this width strip. We'll put the strip in here. And then we will be able to crank the handle. And it's almost like a pasta maker, right? You crank the handle, in goes one strip, and out comes two. Okay. This is another place where our thickness gauge is useful. If we fold the rubber over on itself like that and put it under the anvils of this thickness gauge, we can see that this rubber is 85 thousandths wide. Okay, so that's not a bad starting place. 85 thousandths wide is not a bad place to start. So we would cut off enough of this rubber to make a motor. So here's a piece. You guys have pre-stripped motors there. I cut them out of some other strip that I had. This didn't have a knot in it. It would go faster. So some people say wet the rubber before you strip it, and some people don't. And honestly, I never do because I don't want to get water all over my stripper. Now I'll just tell you, I had the interesting conversation with my principal when I sent him an email that said, "Hey, I'd like to get a stripper for my flight endurance program," and he goes, "I'm sorry, Mr. Baggins, I need more information," and I was certain that he did. I told him it was a rubber stripper, so I think he really was wondering about me then. But it's a really handy tool. There's different brands. This is the only one I think that's currently in production that's not ridiculously expensive. There's another one that's called a Johnson or a Guga rubber band cutter that's still available, and it cuts a little more square on the strip, and it's $1,000. It's $1,000. It's $1,000. I don't have one of those. Yeah, I don't think so. So anyway, we're gonna make a loop of this rubber. We're gonna make a loop of this rubber band. Remember that the motor size is not determined by the size of the loop. The motor size is determined by the mass. So we'd put this back on our scale, and we would check it. See if I can get this where y'all can see. Put the rubber band on there and check it out. It's 1.4 grams. I have my eyeballs calibrated last Thursday. And then we're going to take this and O-rings. Did I give them to, what did I?
On how much motor weight?
Oh, 1.5 grams. The scale is acting funny. I don't know why. Maybe my batteries are going dead. Oh, I know why. I'm an idiot. All right, so it's a little bit over. So again, for the purposes of our demonstration today, I wouldn't worry about the mass of the motor as much. We are not in competition here. We are just trying to make sure our little plane will do something. we put the O-rings on the rubber. The O-rings let us transfer it from the winder. Transfer it from the winder. So you see I got 2 of those little black O-rings. I gave y'all some in your bag with your rubber band. And now I'm going to tie a knot. Those scouts in here and sailors will be able to tell me what kind of knot this is. I don't know. It's the knot that keeps my rubber band from popping loose. Well, I just broke that piece. You got to be careful with your fingernails, guys, because your fingernails will make nicks in the rubber and then it'll break. So I did that, and then I tied the tails together and pulled them up against it. And then I trimmed that off because the tails are just along for a ride. They don't get wound. And then we're close. We're at 1.5 grams. Beautiful. All right. So if I were flying for real, I would always make sure that I put some kind of lubricant on the rubber. Andy, would you do me a favor? Would you look in my toolbox there? In the bottom of it, there's something that looks like a tube of toothpaste. Thank you, sir. So I use this as lubricant, this 3M, this Dow Corning 3M, I keep saying 3M, this Dow Corning Molly Coat lubricant. And the tube is expensive, but you just use a little dab like Brill Cream. And you put that on the rubber band to lubricate it. A really inexpensive alternative is Armor All or STP, or like Son of a Gun, not STP, but Son of a Gun, any of those protectants, vinyl protectants, whatever. And we just put some of that on there, and I get the kids to be methodical, so they lubricate the rubber band every flight. The rubber band is weighed without the lube though, so they can wipe it off before they go back to the judge's station. That's important. Now, in your box, I gave everybody a winder. Your winder is 20 to 1. So I have a 20 to 1 winder here, but mine doesn't look like yours. Mine is a Wilder metal. It's got metal gears in it. They don't make these anymore. I've got this from an old friend of mine who was getting rid of it. So anyway, the winder just spins the output shaft, in this case 20 times as fast as you crank the inside. And we can wind this motor up. We can wind it on the plane, but we have to have somebody to hold it for us. And since you guys are all by yourselves, I'm going to show you another thing that you might use. So this is a torque meter. So this torque meter is ancient, but it's what I got in my toolbox right now. This torque meter, you hook the rubber band on the hook on the end right here, and as you wind it up, it twists the wire that's inside of it, and it twists it around, and we can read these numbers. It doesn't matter the calibration as long as you always fly with the same meter. If you can control how high your airplane flies with any particular prop and rubber combination by the torque that's on the motor when you launch. And we could spend another 2 or 3 hours just talking about hysteresis and the properties of the elastic motor. We don't have that time to do that. So with this thing, you'd clamp it to the table. You would hook the rubber band. Andy, I'm gonna get you to, if you would, to just hold this real quick. I want to show them how to, very quickly here, how to transfer the motor. So I'm gonna wind. I'm only gonna wind a little bit. Just hold that down. All right. So what I'm able to do now, you guys can see, I've taken them. I use the O-ring as a place to hook the rubber, the winder, and the O-ring doesn't get wound up. The O-ring is much stiffer rubber than the band, so the O-ring never closes up, and I can take it right off the winder without losing any wires. And then I can, if I can get this off the stand, there we go. So now I can hold my airplane. Let me switch cameras so you guys can see. Andy, I'm sorry you're in a bind, but
I'm fine. Been there, done it before.
all right. So you can see now, guys, I can take the back of the plane here, and I can hook the rubber band on that rear hook. And then I can disconnect from the torque meter, and I've got the front end up here, and I can turn my prop hook down like that so that it's open at the bottom. And I got too many things here. But then I can hook the rubber band on there like that. Okay. So now you can see why we needed to have those spacers on the back hook. We needed that space so that those knots don't hit the stick. And we see that helps us keep everything in alignment. Now let's see if we put this wing, and I'm eyeballing it, that looks about right to me. And I'm going to try to adjust the angle of the tilt of the stabilizer a little bit. See, by putting the wing, as you guys can see how the wing and the stabilizer aren't in the same plane? And I mean, I don't mean the plane like the airplane. They aren't in the same plane in space. They're at an angle to each other. And that helps us fly in a circle. So we have three ways to fly in a circle. We have the angle of the propeller forms with the motor stick, the angle that the stabilizer forms with the wing, and the angle that we put the tail boom on at to the side. Remember that space, we use the nickels underneath the stick and space that out. So I'm gonna fly this around the room and let's see what it'll do. Yeah, I call that good.
I'm going up.
Yeah. That actually flies all right.
Let's see, with my screen, I got my camera on.
So put 400 turns in it. We'll try it again. Let me wind it up a little bit more, guys. Andy's gonna hold his computer up.
So let me come up back there.
So Grant, that piece of plywood is for me to do. I'll tell you that it's for me. Right. Tell me when you're ready, Andy. All right, let's see, guys. We're going to give it a try here. So Andy's going to try to. Well, can you unspotlight me? And spotlight. Let me see if I can. Let me see if I can do it. Yeah. You got it. You got it. Okay. All right. So we're changing cameras here.
Now your spot.
Whose camera are we supposed to be watching?
We're going to try to spotlight Andy's camera.
Can you see me?
Yeah, I can see you. You're the main one. You're the main one on my screen. Yeah.
Not on mine. Let me see.
All right. I turned mine off, so you should be in the spotlight now, Andy.
It says I'm spotlighted.
Okay. It should work now.
This one.
You'll see what
Stephen, what's your main screen that you see? Oh. Stephen, what's the main screen you can see?
I can see you just fine.
Okay, I'm on the main screen. Okay.
So here we go. I'm going to give it a try in the shop. You guys can see my ring is a digest because it's furniture, equipment everywhere. We're going to give it a try. So here we go. Hello, Ben. Way too loud.
I can't see if I can see it. Can you see the plane?
I can see.
Okay.
All right. So wish we had time and in person we could go to the gym and look at a lot of stuff about flying. Talk about more stuff about winding. Talk about more stuff about rubber band selection. Again, I want to share a whole lot of resources with you guys that I will send out in the next day or two. I will also always be available to answer any questions about anything at any, pretty much any time. I am going to be getting ready to go to the national to AMA Nats in the next few weeks, so I'd love to chat with anybody about airplanes that would like to. And are there any questions about anything and the things that that you guys found challenging, things that work well? Please let me know. Like I said, it's my first go with a virtual workshop, and it's easy to fix things in person. A whole lot easier to fix things in person than it is to fix things when y'all are hundreds of miles away. Yeah. Okay. All right.
In the last half hour, Mark sent y'all an email with a link to a survey, and you'll need to fill out the survey so that you get your PD certificate. So don't forget to do that, okay?
Hey, I do have a couple questions.
All right. That's all I had.
To go. What was this little piece here for? It's like just like a little bitty piece of dowel rod. You're muted.
All right, I'm back. So on your stand, you use a regular clothespin and the clothespin spring. Well, to make the stand more universal, especially if you decide to build any lighter planes with your kids, if the motor stick is really light and soft, this spring is too strong. So what you would do is you take the clothespin apart. You take the clothespin apart and you glue the dowel, that little piece of dowel, to one side of the clothespin, and then you wrap some rubber band around it like this. And by sliding the rubber band up and down and putting that dowel in there, you can make the spring as soft or as hard as you want. And it really makes it easier on the softer wood motor sticks that you have to use for lighter airplanes. So I put that in all of the kits in case you want to modify your original clothespin, but that's what it's for. These sticks are hard enough that the original clothespin spring is fine, but that it works better like on penny plane and lighter, anything that's lighter than that. Work better to have an adjustable lighter spring here.
Okay. The other question I had is on our sheet with the red wings, what was the drawing at the very top?
All right, so that drawing is a template that's actually drawn to the size and shape of the inside of the wing. And what you would do is you'd carefully cut that out with a straight edge and some scissors, and you would pin that down over the plan. So you put the plan down, you pin that down over the plan, and then you can pin the spars up against it, hard up against it, and it keeps everything straight. It's just one of several ways to hold the part still, while you are gluing them together.
Okay, I got you.
And honestly, maybe with the kids, that template is the best way, probably. But and that's one of those things that's easier to make with the laser, because you can just take that drawing and put it in the laser and cut it out.
Yeah.
But if you got to do it by hand, it's time consuming. But once you've made a set of them, you're at least good for 2 years, or until TSA changes the dimensions of everything again, or you decide that the kid decides to change the design. So that's what that's for.
Okay.
With how many turns do you do on this to wind this up? I mean, when do you know it's enough?
Oh, okay. Well, we wind it until it breaks, and then you back up one. Yeah. So no, there's a formula, and for those that are inclined to be really nerdy like I am, so it's 38 times the length of the loop. So for instance, on your plane, the loop might be 11 inches long. So it's 38 times the length of the loop times the square root of the length divided by the mass. So, and that tells you a safe number of amount that you can turn it. Remember that your winder is 20 to 1. And so you divide that number by 20, and that's how much you should wind it. I would think that the rubber band that I gave you would take about 45 to 50 turns of your winder handle, which would be about 1,000 turns. And you would utilize something called stretch winding. So you got to be able to wind the rubber off the plane usually. And so what you do, you could put a screw eye, open up a screw eye so that it's got like a hook, put that on a board and clamp that to the table, and then hook the rubber band to it. And you're going to stretch it out about 4 times of its relaxed length at least, and start winding. And when you get to, say, like if you're going to wind it all the way up, when you get to halfway, like if you're going to wind it to 40, when you get to 20, then you start coming in until you're at the length of the hook to hook, the hook to hook on your plane. So there's a lot there about winding that we could go into. But yeah, 38 times the loop length. And it's crazy, the mixed units. Somebody did a lot of math to make this work out to be a number. It's a fudge factor in there somewhere. But 38 times the loop length times the square root of length over mass. That'll give you an approximate safe number of winds for most of the rubber that we buy today. You can also do it empirically. If here's the thing you can have your kids do. Talk about material properties. You can actually make up little short loops, and say a 4-inch long loop, and you can have them wind it to failure, wind it till it breaks. And if they make 3 loops that are the same, and they know the mass, and they know the length, and they know the winds to failure, they can calculate for that width of rubber the turns per inch to breaking. And that's neat. That's neat math to have them do. It's a great experiment to have them show how. Then they can compare that to the theoretical from the 38 times the loop length times that, and see, am I close to that? And it is. Somebody did a whole lot of empirical experiments to come up with a theoretical solution. So it's all fun.
Can you send us that formula?
I will. I'll send you all kinds of stuff. I'll send you some links. There's a really neat article about rubber testing for those of you that teach engineering. There's some neat things about testing the stiffness of boards. So you're testing the stiffness of the balsa strip using the like the Euler buckling load test. Where you put it on a scale and you push down until the wood buckles to the side, and then you calculate the density and you calculate the length and the width and all of the strip, and you put it all into this Excel spreadsheet, and it tells you the stiffness coefficient, and that tells you which piece of balsa wood to use for which part of the airplane. So there's all kinds of cool stuff I'll be glad to share with you, but that wasn't really exactly relevant to what we're doing today, because we just had to get through building an airplane today. So how many people, hit me up in the chat, how many people got their airplane finished or confident that they can finish it from what we saw today?
I don't have the chat pulled up, but I did get mine finished, except for I need to find some thinner needle nose pliers to be able to get my other wheel on. For some reason,
Yeah.
The piece too big.
Well, no, I mean, it just depends. Like I said, I didn't make those things to micrometer precision, those landing gear pieces. And so some of them are longer than others. And I didn't tell you guys what size needle nose pliers to have either. So not all needle nose pliers will fit in there. It needs to be pretty small. All right.
Well, my needle nose pliers didn't have the notches. I liked how yours had the notches.
Yeah, it's very helpful. It works really as a good way to gauge wire when especially like when you're making the hooks. And I have a whole array of little pliers that I use, just like any other hobby. You just accumulate tools as you're trying to figure out how to do different things. Sometimes some models, the rubber band is so long between, because you're not limited on the mass of the rubber. You got to have a way to keep the knots from creeping up on the hook. So you use a different kind of hook to keep that from creeping up. And so that's another topic for another day. TSA, because it's a rubber band weight limited class, It's a lot to do to figure out how to wind well. I mean, you got to be able to wind to within an inch of the rubber band's life. You know, it's got to be absolutely as tight as it can go, and you got to have the right size so that the airplane can absorb all the energy from that rubber band being wound just as tight as it can be. Because at the beginning, it'll almost climb straight up if it's got enough power. You know, but pretty cool.
So we're going to take, are the teachers going to bring theirs to TSA and have a competition amongst us?
That would be fun. That would definitely be fun. We do that in Virginia at our state conference. We have that. We do dragsters and we do airplanes. So it's fun, and I mean we let the kids enter too. So we just all play. You know, it's fun after the contest because then you get to make as many attempts as you want, and we just have fun with it. You know, we usually have a mixer at TSA. Andy will tell you we usually have a mixer at Virginia TSA at the end, and I have a lot of kids that like airplanes so much that they skip the mixer and come fly model planes with us. So, you know, it's all fun. Plus, our state site is terrific. You know, our state site is, you know, big high ceiling and gigantic ball. You know, big giant convention center space. So it's awesome. So I appreciate you guys letting me do this. I appreciate you all signing up. I really hope that, you know, I really hope to see you guys at National Conference flying with your kids. Please let me know if I can do anything to help you, any resource that I can share with you, any material I can share with you, anything. So it's like I said, it's much better face to face. We would head down to the gym about now and turn the air conditioning off and fly for a little while, and then we would have some food, and then that would be the end of our day. So